have seen about the algorithm. Algorithm is a step-by-step procedure to solve a given problem, and we have also seen about algorithm and program. Algorithm is a step-by-step procedure to solve a program, and program is an implementation of the algorithm. For algorithm, we should have a domain knowledge. For program, we should have programming knowledge. The characteristics of algorithm are well-defined finiteness, effectiveness, and definiteness. And we have also seen about asymptotic notation. Asymptotic notation is the mathematical concept which describe about the time complexity and space complexity. The time complexity is nothing but it is the time required for the compilation of program, and space complexity is nothing but it is the space that is required for compilation. In asymptotic notation, we have three cases: worst case, best case, and average case. And now we are going to see about sorting and its types.
Today we have to see about sorting. First we see about sorting. What is sorting? Sorting is the process of organizing the data and the arrangement of the data in an order. Typically, either ascending or descending. It depends upon the types of the elements. It is one of the most fundamental operations in computer science and data management system. It is easier to search, analyze, and process. Sorting is widely used in various applications such as database management, searching algorithms, and data visualization. There are 9 types of sortings. First one is bubble sort. Second one is insertion sort. Third one is shell sort. Fourth one is direct sort. Fifth one is bucket sort. Sixth one is counting sort. Seventh one is heap sort. Eighth one is quick sort. First we see about bubble sort algorithm. Bubble sort is the simplest sorting algorithm that work by repeatedly swapping the adjacent elements if they are in wrong order. The algorithm is not suitable for large data set as its average and worst case time complexity and quite high. We sort the array using multiple passes. After the first pass, the maximum element goes to in. Same way, after the second pass, the second largest element goes to the second last position, and so on. In every pass, we process only those elements that have already not moved to the correct position. After k passes, the largest k element must have been moved to the last k position. In a pass, we consider remaining elements and compare all adjacent and swap. If larger element is before a smaller element, if we keep doing this, we get the largest at the correct position. Let's see about the advantages and the disadvantages of bubble sort. Advantage of bubble sort. Bubble sort is easy to understand and implement. It does not require any additional memory spaces. It is a stable algorithm, which means that elements with the same key value maintain their relative order in the sorted output. Disadvantage of bubble sort. Bubble sort has a time complexity of O of n squared, which make it very slow or large data sets. Bubble sort is a comparison based sorting algorithm, which means that it requires a comparison operator to determine the relative order of an element in the input data set. It can limit the efficiency of the algorithm in certain cases. Next is selection sort.
Selection sort is a straightforward sorting algorithm that organizes data from smallest element to largest element in the unsorted part of the array and swapping it with the first unsorted element. The process divides the array into two parts, sorted and unsorted. In each iteration, the smallest element from the unsorted section is moved to the end of the sorted section. This continues until the entire array is sorted. Although simple to implement,
sort. In this sort, we are going to use two types of list. One is sorted and another is unsorted. Generally, before our pass case, we will initialize I position in index 0, and we will consider the index position 0 as the sorted element, and we will throw the element to sorted list. After in pass 1, the I value get incremented by 1. So it will check the previous I position. Either if it is smaller, it will swap the previous it will get swapped the previous element. If it is not, it will maintain the same. And again we will throw the I value to the sorted list after the comparison. In second pass, the I value again it will be get incremented by 1. Now the position of I will be 2. So again it will check with previous I value. Either it is smaller than previous value, it will swap with that value in sorted list. The passes will be continued. In insertion sort, we have time complexity because in every pass the I value have to compare with previous value of I, so it needs much time to get compared. And we have also space complexity as it is used two types of list. So while storing the two lists, we need much spacer, so we have time complexity. Next we are going to see about heap sort.
Heap sort is the comparison based sorting algorithm that uses a binary heap data structure to organize and sort data. It is an efficient and in-time-based sorting algorithm with a time complexity of O of n log. How does heap sort works? It begins by max heap. It converts the input array into a max heap where the largest element of the array. Next is extracting elements by swapping the roots with the last element in the heap. Reduces the size by 1 and restore the max heap property for remaining heap process. Next, it repeats the process. It continues in the process until all elements are extracted, resulting in a sorted array. Next is key features. The first one is increase. It requires only a constant amount of additional memory. Second of all is not stable. The relative order of equal elements is not preserved. Moving on is efficiency. It is suitable for large data sets due to its worst case performance. Moving is a step between these. The first point is it builds a max heap from the input array. Second one is it performs heap sort by repeatedly removing the maximum element and being defined. Next is applications. Here it uses priority queue implementation. Next is sorting large data sets. Let's more talk about advantages and disadvantages. First is advantage. It is predictable time complexity. It does not require additional storage like registry. And next is disadvantages. It is slightly lower in practice than quick sort for many cases due to the overhead of maintaining a heap structure. So that is all.
The summary of this session, sorting is a technique which is used to arrange the list of elements either in ascending order or descending order. We have different types of sort: bubble sort, selection sort, insertion, heap, quick sort, merge sort, etc. And in this session we have learnt about bubble sort. Bubble sort is a simple type of sort. It will compare with the adjacent value. If it is greater, if the adjacent value is greater, it will the I value get iterated, or it will swap with I value. And selection sort is a type of sorting technique. The I value will be in the initial position and it will compare with the least element in the list and it will swap with I position. And insertion sort is a type of sorting where we have used two types of list. It's namely sorted and unsorted. Here we initially take initial I value 0 as sorted element, and in pass 1 we will compare with previous I position. If it is greater, we will swap with I position and previous I position in the sorted list. And last we have seen about heap sort is a type of sort where we have used tree concept, and in heap sort we have 3 steps. First we have to create a sort, then we have to heapify the sort. It is nothing but either we have to make a tree like minimum heap or maximum heap,